Hello everyone, welcome to exam prep section 2. Now we'll go over the worksheet. So this week's worksheet is composed of two very small problems and one larger problem for EDA and PANDAS. So maybe let's start with some PANDAS 3 lecture questions. The first one uses the exact data frame as the first question of our first worksheet in the semester. This data frame PANDAS contains two columns, age and height, for several pandas across the world. And now the zoo manager sends you another data frame, mothers, which stands for the mother-children relationships for the pandas in the above data frame. Now, we want to write a line of pandas code to add a new column mother to the data frame panda that contains each parent panda's corresponding mother. So let's look at the two data frames together. Basically, we want to add a column of mother where my mouse is circulating around, such that each name is a child that corresponds to another mother. Alright, so how do we do that? Basically, we just want to match each row within mother to each row within the panda data frame based on the child and the second data frame and name in the first data frame. So actually, a very natural solution here would just be to use pd.merge. So we're going to merge the data frames panda and mothers. Here we have to decide which columns we're going to merge by. In this case, left one will be name because name is the name of the column that we're going to be using for merging. Right on is going to be child instead because that's the column we're going to match towards in the right data frame. Last but not least, since name and child would actually be duplicated columns, you can drop one of the columns by saying drop of column is equal to, well, in this case, you could drop either name or child, but dropping child here makes more sense in the end result. So we'll say columns is equal to child. And that will be the solution to this question. Now we can move on to the second question, where we reuse the data frame, but we talk about a subpart that we didn't talk about last time because it involved an advanced pandas call that was only taught this Tuesday. So review this data frame called ath, where you have each row corresponding to one athlete's record at some kind of competition. Well, actually, this is an Olympics competition. So write a line of pandas code that creates from ath a table with rows for teams, columns for sports, and the average age of female athletes for each row column combination as each cell's values. Here, there are a couple of things we need to do, but it can be simply divided into two action items. We need a table for female athletes and a table with rows as teams, columns as sports, and average age. So this table part looks very doable from a pivot table standpoint. Now what we need to do is to first try to filter the data frame such that the data frame only contains female athletes, and then we can do a pivot table call. So let's first filter down the data frame such that it only contains female athletes. Then what we want to do is just to call pivot table on it. So usually when we're calling pivot table, it's pretty hard to memorize the order of the argument. So that's why usually we always, or not always, but usually just say the argument name is equal to some column name instead of having to memorize the order. So in this case, the value we're going to aggregate over is age. The rows are going to be teams. So we're going to say index is equal to team. Columns is equal to sports for obvious reasons, just like the question description. And we also have to say agfunc, which is the function of aggregation, is mean, so that we get the mean age. And last but not least, you can occasionally fill in a fill value is equal to 0 in case there's any missing values. Okay, so that's good. All right, now let's move on to the larger question, which merges some EDA question and the pandas question. So let's introduce the dataset a little bit first. This dataset I don't know this artist, but you probably do. So this data frame is a data set from Billboard Hot 100, which is an American music chart. And we will be investigating this data set called Billboard, which is put inside a data frame. So here you have several columns and a lot of rows. This is the first 10 rows of the data set. As with any good EDA, you try to understand the variables included. Of the variables song, performer, time on chart, and consecutive weeks, which of the followings are quantitative, qualitative ordinal, and or qualitative nominal? In this case, we see that song and performer are just names of a categorical variable, and it's also qualitative because it just describes a feature that is not numerical. So song and performer are qualitative, nominal. If it's ordinal, it means that there is a specific order hidden within the variable itself. But in both the cases of song and performer, there's no inherent order to these variables. Now, time on chart has a numerical meaning, and so does consecutive weeks, which also has a numerical meaning. Because they have a numerical meaning within them, you can say it's quantitative. When something has numerical meaning, it means arithmetic makes sense for these variables, or that these variables have to be described with numbers, or else it cannot be described at all. Okay, now let's look at other variables. Chart position and chart data are a little bit harder to categorize and largely depend on what we're doing with the data set. How would you categorize them according to the last part, and why? Here, chart position is at a very tricky state. You can say that chart position is a rank. A rank can be said as qualitative ordinal, because adding up ranks doesn't make sense. But you can compare ranks. But there's also some numerical meaning into the rank of something, and you can actually use the rank of something to make a lot of statistical analyses that other more advanced research does. So it could also be said as quantitative. The solution of the worksheet would say is qualitative nominal, qualitative ordinal, but some people would also say it's quantitative. This is the more popular answer there, that it's qualitatively ordinal. All right, and then chart date is mostly a quantitative variable because it measures time in a numerical form, and you will mostly do numerical operations with it. A date would not be qualitative because a date has to be mentioned or described in the form of some numeric form. Okay, now let's move on to questions that have more concrete answers, such as part C and follows. So in part C, now we only want an assessment of this singer's music, so we're going to obtain a data frame with only this person's entries. So we can look at the data frame again. The column that corresponds to the name of the performer is the performer column. So we can do Boolean indexing here, where Nikki, this data frame with only the specific artist, is equal to, well, the original data frame is called Billboard. And then you would put a Boolean here that stands for entries, where this person is the performer. And apparently the performer name is Nicki Minaj, so we'll just write it like that. And then there's the solution. Okay, so this is Boolean indexing, which you have done in your homework to the day that I recorded this. Okay, now in this new Nikki data frame, are there missing values in consecutive weeks column? Write a line of pandas code to return the amount of missing values in this column. Well, we can't see whether there's any because there's none of the rows that are exhibited here has Nicki Minaj as the performer. but we can calculate how many missing values there is by first trying to get whether something is a missing value inside the column of consecutive weeks. And the way we do that is through isNull. So sometimes it looks like I'm pulling a method out of nowhere, but usually this is either because someone has already done a lot with pandas, which makes it easier for them to pull out the function they will need, or basically you will be given a midterm reference sheet where every method you need for pandas is written on there, so then you can easily reference it. Okay, so now I have come up with a series where true means missing value. So you can just sum over them and get the total number of consecutive weeks that are missing values. Okay, and we can quickly move on to the next subpart once again. Assume all columns do not have missing values except consecutive weeks, which we can see in the above image. Why do you think that value is marked missing? Would you input anything for it? Here, impute means giving an educated guess. So let's look at the data frame first. The only instance of a missing value is when time on chart is 1, which means it was 1 week on the chart. Well, actually, if you're just 1 week on the chart, then it doesn't really make sense that you have consecutive weeks on the chart, right? Because let's say it's your first day that your song lands on the chart, but not even a week has passed, so consecutive weeks will, of course, be missing value. Because being on the chart 1 day doesn't equate to any number of consecutive weeks except 0. So actually, applying that logic, we could say we would impute 0 for it because it makes sense according to our analysis that we just made. Okay, a more concrete text-based description can be found on the solution, but this outlines the idea for it. Okay, now second last subpart. Now we want to know what the most successful year for this performer was. And success is measured by the number of Billboard Hot 100 entries you had across the weeks of a given year. Write 2 lines of pandas code to return a series whose index is the year and whose values are the number of entries. So now this looks like a group byable thing, but if we look back at the data set, well, we would wish to group by something like year, but there's no column that just gives you the year, so it's a little bit tricky to do group by year and then just dot size or dot count. So what we could do instead is we can try to create the year column, and we can actually find it from chart date. So chart date is a string. If you split the string based on this dash or hyphen symbol, and just take the second element always, then you can actually just get a series of year, or you can just get a column of year. Okay, so now that we have kind of noticed that, we need to talk about how to split a string. But to split a string like that, you could actually just do .str.split, which is actually already in the hint. What a coincidence, haha. Okay, so let's create the column for year, which is doing str.split on the time first, which is also called chart date, to a .str.split. Remember, you cannot just .split because .str and .split are kind of grouped together. You can use .split because you have put in .str. Okay, we want to split by this horizontal thing. And then if you do this, to access the second element, you can do .str2, but there's another choice here, which is you can use the expand is equal to true argument and target the second column, and that will also serve the same purpose. You have actually done this trick in the homework that you are supposed to submit today. Okay, that's fine. So we have a year column. Now we just have to group by it. So Nikki.groupBy of year, and then .size, then we'll get the number of elements per year. Okay, that was That was a little bit tricky, but as soon as we can come up with a strategy along which we want to go with, we can just write all the code for each step of the strategy. Note that there are two tricks that are particularly useful when you're having this kind of problem where you need to decide a strategy, which is to first write out all objectives of the question. In this case, you need a series whose index is year, whose value number of entries. So you know from the beginning that you have to somehow come up with a column that has year so that you can have a series whose index is the year. So nevertheless, we will create a year column. And then we want to get a number of entries per year, so that sounds like a group by thing, which you can just use as the second line of the code. Now let's talk about the last part. You find her most successful year to be 2012. Should you conclude that her music was most globally popular in 2012, but then she has fallen off? Present two reasons in favor or against this conclusion. Now, first of all, we can look at what the dataset was collected with. So you'll see that this dataset is Billboard Hot 100. But this data is actually based only on Americans. Just because your music is not popular in America doesn't mean your music is not popular somewhere else in the globe. So the statement of globally popular is actually already wrong. It is not most globally popular in 2012, it's just the most popular in 2012 in an American population. Okay, so that's one argument we can provide, which is that this is actually wrong. It's not global, it's just American. In the context of this question, okay. So, now, next, there is another reasonable reason, which is, there's another reasonable answer, which is that maybe being put on Billboard is just not a standard of being popular, right? Because this Billboard record that we got the most popular from was from 2012, where a lot of streaming services that a lot of traffic goes through is not really recorded. So maybe the population in Billboard just dwindles over, maybe the amount of traffic you get recorded by Billboard Hot 100 is not a good indicator of being popular. Someone can be not so popular on the Billboard, but extremely popular on other streaming services, such that they're actually more popular than other people recorded on a Billboard. So the second reasonable reason could be something like the Billboard is not an absolute indicator of popularity. Okay, so that ends the worksheet. Good luck and have a nice weekend. Bye.